Isn't it bizarre to think that it's humans, you know, when we're filling up our car, turning on our lights, that we're the ones controlling climate? Just look in the sky. Look at that massive thing, the sun. Even humans at our present 6.5 billion are minute relative to that.
In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that. So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds. Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Neer Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compare the graphs, just put them one upon the other, and it was just amazing.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected, but now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration. To the Harvard astrophysicists and many other scientists, the conclusion is inescapable.
The sun is driving climate change. CO2.
Paul Driesen is a former environmental campaigner.
My big concern with global warming is that the policies being pushed to supposedly prevent global warming are having a disastrous effect on the world's poorest people.
Global warming campaigners say it does no harm to be on the safe side. Even if the theory of man-made climate change is wrong, we should impose draconian measures to cut carbon emissions just in case. They call this the precautionary principle.
The precautionary principle is a very interesting beast. It's basically used to promote a particular agenda and ideology. It's always used in one direction only. It talks about the risks of using a particular technology, fossil fuels, for example, but never about the risks of not using it. It never talks about the benefits of having that technology.
Anne Muagela is about to cook a meal for her children. She is one of the 2 billion people, a third of the world's population, who have no access to electricity. Instead, they must burn wood or dried animal dung in their homes. The indoor smoke this creates is the deadliest form of pollution in the world. According to the World Health Organization, 4 million children under the age of 5 die each year from respiratory diseases caused by indoor smoke, and many millions of women die early from cancer and lung disease for the same reason.
If you were to ask a rural person to define development, they'll tell you, yes, I'll know I've moved to the next level when I have electricity. Actually, not having electricity creates such a long chain of problems, because the first thing you will miss is the light. So you get that they have to go to sleep earlier because there's no light. There's no reason to stay awake. I mean, you can't talk to each other in darkness.
No refrigeration or modern packaging means that food cannot be kept. A fire in the hut is too smoky and consumes too much wood to be used as heating. There is no hot water. We in the West cannot begin to imagine how hard life is without electricity. The life expectancy of people who live like this is terrifyingly short. Their existence impoverished in every way. Africa has coal, and Africa has oil. But environmental groups are campaigning against the use of these cheap sources of energy. Instead, they say Africa and the rest of the developing world should use solar and wind power. A short drive out of Nairobi, we find our first solar panel. A Kenyan public health official has brought us to a clinic which serves several villages. The only electrical implements in the clinic are the electric lights and a refrigerator in which to keep vaccines, medicine and blood samples. Electricity is provided by 2 solar panels.
So what can it do successfully?
Lighting.
Lighting only?
Yes.
What happens when you put lighting plus the refrigerator and others? What happens?
It sounds an alarm.
It sounds an alarm?
Yeah.
Then can we maybe see that?
The solar panels allow Dr. Samuel Mwangi to use either the lights or the refrigerator, but not both at the same time. If he does, the electricity shuts down. Wind and solar power are notoriously unreliable as a source of electricity and are at least 3 times more expensive than conventional forms of electrical generation.
The question would be, how many people in Europe, how many people in the United States are already using that kind of energy? And how cheap is it? You see, if it's expensive for the Europeans, if it's expensive for the Americans, and we are talking about poor Africans, you know, it doesn't make sense. The rich countries can afford to engage in some luxurious experimentation with other forms of energy. But for us, we are still at the stage of survival.